Assalamu alaikum. How are you, students? I hope all of you are well and safe at your home. This is Rizwana Mukhtar, lecturer, Department of Physics. Today I am going to solve two creative questions from chapter 5, which is states of matter and pressure. I hope this lecture will help you for your better study at home. Our today's first creative question is from Dhaka Board 2019, and the question is that the density of liquid in pot A and B are 800 kg per meter cube and 1260 kg per meter cube respectively. The height of the liquid in pot A is 50 centimeter. Due to dip an object of mass 250 gram in liquid in pot A, it losses of weight of 1.96 Newton. So actually what the extreme is, here you can see that there's a diagram. It will help you to understand the stem. Here's two pot filled with liquid and the density of liquid in pot A is 800 and pot B 1260 kg per meter cube, and there's an object with mass is 250 gram. When this object A is deep into the pot A, then the object lost weight, and the lost weight is 1.96 Newton. And another one information is given here. The height of this liquid is 50 centimeter. That is 50 centimeter. Now our question number C is that find the pressure of liquid at the bottom of the pot A. That means we have to identify the pressure of pot A. So here's the given informations are for question number C, height, H is 50 centimeter. When we convert it into meter, then we will get 0.5 meter. The density of liquid A, density, that is rho A equals to 800 kg per meter cube, and we have to calculate the pressure, that is pressure P equals to what? And you know that to identify pressure into liquid, we know the formula is P equals to 8 rho G. Now I am going to put all the informations that are given here. Height is 0.5, rho 800, and you know that the value of acceleration due to gravity is 9.8. So after calculating it, you will get the answer. The answer is 3.920 Pascal. Now question number D. The question is, what will happen if the object is fallen in liquid in pot B? That means if we dip the object in the liquid of pot B, then whether the object sink into that liquid or float in that liquid. That is the question of D. So let us start. So we have to calculate the weight of that object and the buoyancy of pot B. Then we can say that whether the object will float or sink. So here's the given informations are for question number D is density of liquid in pot A, that is row A, is 800 kg per. Now the density of pot B is 1260 kg per meter cube. Density of liquid in pot B, that is row B, equals to 1260 kg per meter cube. Now the mass of the object is 250 gram. Mass of object M equals to 250 gram, and by converting it is into kg we will get 0.25 kg. Now lost weight of the object when it dip into the pot A, that is lost weight in pot A equals to 1.96 Newton, and we have to calculate the weight of the object and the buoyancy of pot B. That means weight W equals to what, and the buoyancy that is F equals to what? Now we know that the formula to identify weight is W equals to mg. Now I am putting the value of m, that is 0.25, and the value of g is 9.8. So by calculating it, you will get the answer is 2.45 Newton. Now we have to calculate the buoyancy force. You know that to identify buoyancy we need to know the volume of the object, but here you can see that there is no information is given to identify the volume, but there's one thing is given, that when that object is put in the liquid A, then it lost its weight 1.96 Newton, and from the definition of buoyancy we know that the lost weight is equals to the buoyancy. So we can write that the lost weight equals to the buoyancy in pot A. So the formula will be V rho A G. That means V equals to, just we are changing the side, here's the lost weight, that means V equals to lost A weight by rho A g, and the value of lost weight is 1.96 divided by value of rho A equals to 800 and g is 9.8. So after calculating it, you will get the value of volume is 2.5 into 10 to the power minus 4 meter cube. Now it will be easier for us to calculate the buoyancy in pot B. Buoyancy in pot B, that is F equals to V rho B G. Now the value of V is given here 2.5 into 10 to the power minus 4, and the value of density of liquid B is 1260 and the value of G 9.8 meter per second square. So by calculating it, you will get the result of buoyancy force, and that result 3.097 Newton. So now we have both informations. The buoyancy force is 3.097 Newton and weight, that is W equals to 2.45 Newton. As you can see that the weight is less than buoyancy. That means when the object is put on the liquid B, then this object will float by partly immersed in that object. I hope you understand it. Now, second creative question. The question is that Imrose used two bodies A and B having cubic and spherical shapes respectively in a vessel filled with water of density 1020 kg per meter cube according to the figure. Here you can see the figure. There's an object A which is cubic shaped and object B of 20 gram which is spherical shaped, and a vessel which is filled with water. Now our question number C is find the density of the body A. That means we have to calculate the density of this cubic shaped body. So the question number C is find the density of the body A. Question number C is find the density of the body A. So here the given informations are, in case of A, mass M equals to 20 gram. That means 0.02 kg. Now the length of one side L equals to given 2 centimeter. So by calculating it, you will get 0.02 meter. As here the length of one side is given, so we can easily identify the volume of object A because it is a cubic shaped object. So the volume of the object will be V will be L to the power cube, 0.02 So by calculating it, you will get the answer 8 into 10 inverse 6 meter cube. Now we have to calculate the density. Rho equals to what? And we know the formula to calculate density is rho equals to m by v. Now we know the value of m and v both. So I am putting the value here. M means 0.02 and the value of volume is 8 into 10 inverse 6. So the density of the object will be 2500 kg per meter cube. And this is the answer of question number C. Now question number D. The question is whether the buoyancy of the two bodies in water will be same or not if both are kept in water. That means we have to calculate the buoyancy of object A and object B. So here in case of A, the given informations are mass, M equals to 20 gram, that means 0.02 kg, and we have already calculated the volume of object A in question number C, that is 8 into 10 inverse 6 meter cube, and that density of the liquid is given here. Rho equals to 1020 kg per meter cube. Now we have to calculate the buoyancy of A. Buoyancy of A, that means FA equals to what? And we know that the formula is F A equals to V rho G. Now the value of volume is 8 into 10 inverse 6 and the density 1020 and the value of acceleration due to gravity is 9.8. So after calculating it, you will get the answer is 0.08 Newton. Now we will calculate the buoyancy force of B in the similar way. Now in case of B, the mass of the object is M is 20 gram. That means 0.02 kg. And as you see that it's a spherical shaped object and the diameter of the object is given 2.4 centimeter. So the diameter D is 2.4 centimeter or 0.024 meter. So the radius of the object will be, radius R will be D by 2. That means 0.024 divided by 2, 0.012 meter. Now the volume of the object V is 4 by 3 pi r cube. The value of pi is 3.14 and the value of r 0.012 to the power cube. So after calculating it, you will get the value is 7.23 into 10 to the power minus 6 meter cube. So in case of object B, if B will be V rho G, that is the volume of object B, 7.23 into 10 inverse 6, and the density of the liquid was 1020 and the value of G is 9.8 meter per second square. So the value of buoyancy force on a B will be 0.072 Newton. As you can see that the buoyancy force of object A is 0.08 and the object B is 0.072 Newton. That means two objects will not feel the same buoyancy. The buoyancy exerted on object A will be greater than the object of B. That is FA greater than FB. So thank you for being with me. Do solve all 2 creative questions by yourself and submit it as a homework to your respective subject teachers. Thank you.